Welcome, everybody, to a Saturday episode of Incubator Weekly. We have Matt with us today after a little break. Welcome, Matt.
Hello.
And we also are straight up showing code. So we're going to jump pretty quickly into the demo. But first, just wanted to talk about high level what we're doing and what progress we've made since the last episode. This is I think part 6 of our decoding platform Rust to JavaScript series. If you could bring up your file browser, Matt, to just open up the files there. So where we left off last time is we were creating an identity from the from Node. So, I'll go even higher level. So the whole purpose behind this effort here is we are creating a JavaScript library for Dash platform communications. And it's built on top of a lot of the libraries that AJ has written that deal with core stuff and encoding, decoding utilities, things like that. And then Matt, you've created a library that uses gRPC to contact Dash platform. Before we were, the last thing that we were able to successfully do was create an identity using the JavaScript library, but we were not able to create documents and contracts, correct? I'm not sure if we actually did that identity part.
Yeah, we did.
As a demo, but okay, we did.
Pretty sure we did.
And now we have documents and contracts, or I should say that in the reverse order: contracts and then documents against those contracts, working in pure JavaScript, using your translated code that takes the Rust library, generates a JavaScript library from those bindings, from those wasm, from that wasm DPP library. Why don't you go ahead and explain the high level how your code works from start to finish, and then we'll go through the 3-step demo of creating an identity, creating a data contract, and creating a document.
Okay, so the thing that starts out with is some Rust code that I wrote that reads the Rust platform source code and looks for all of the struct definitions that are used for encoding messages that are sent to Dash platform in the RPC calls. They use gRPC or sometimes JSON RPC, but then what they're sending is these transitions that are encoded with a binary encoding. That binary encoding is based on a Rust library called bincode. And there was not, before I started working on this, a good way of doing that same bincode encoding in JavaScript, especially in pure JavaScript.
Mm-hmm.
The solution that a few other people have been using has been to compile all of the encoding stuff into a WebAssembly library, a wasm library for Rust, and then importing that into JavaScript. Which is fine for a lot of things, but there are still the occasional situation where the WASM bindings are not ideal or can't be used at all in certain frameworks. Sometimes the tooling that you have to use to actually get them imported doesn't always work very well, or is kind of annoying to debug or whatever. Hopefully you're not having to debug into that kind of stuff either way, but yeah, so long story short, the WASM build of those things is not the way that some people would like to use this, the way that we would like to use it. So what I did was I read all of the struct definitions out of the code and the bin code like annotations that are also in there to alter encoding sometimes, and I'm generating pure TypeScript and JavaScript from that, and making a library that you can use from JavaScript.
Can you pop open the source directory that your mouse is hovered on right there?
Yeah.
So the code that you wrote is actually Rust code that does that
Yes.
crawling through the library that Dash Core group has written, and
Yes.
then spits out TypeScript libraries, right?
So we read Dash Core, and we read RSDPP, and we read RS platform value at the moment. Those are the only ones that I have needed at this point. So we read all of those. We're using the very standard SYN library in the Rust ecosystem. This is used in pretty much all of the procedural macros. So it's very good at reading Rust source code. And then we do a little bit of stuff about like figuring out which ones we actually need. There's a few that we have to hack because they're not actually bin code. But long story short, we then get this generated library, which I have open in a different window. So just a second.
And one of the inputs to this function in general is what branch you want to work on. So you can see the 1.8.1 branch was previous work, and then the 2.0 branch is the current work. So
yeah,
you just pop in whatever branch you want to work with, and then it spits out the latest, greatest TypeScript library for you.
Yeah, and this is valid as of like just a couple days ago was the last time I updated and rebuilt these bindings. So they're still quite fresh.
Yep.
And
this would include all the token stuff as well, but we haven't got that far with just writing a script for it.
There's a bunch of token stuff in here, but I haven't touched it all yet.
Yep. Okay. Let's see. So
that generates this JavaScript TypeScript library, and this is checked in so that you don't actually like if you're using my stuff, you don't have to talk to Rust, you don't have to run the Rust code, you don't have to care about it. Right. You just use the latest generated JavaScript to do this.
These could be separate repos in general, right?
Yeah, they could be.
Yeah.
I mean, they don't need to be, but they could be.
But just for people like me who might be scared of Rust and we're like, I don't want to deal with anything Rust based, you're just saying that, this
check out the Git,
JavaScript developer,
delete that library, and then you're, just deal with the fact that Git hates you for keeping those changes in your repository. But yeah, you don't have to touch it. It's not something that the users need to care about.
Okay, so then what we're looking at here is the first step. Or did you have something to say besides before we look at this --create identity TypeScript file?
Nope.
Okay. So do you want to just do the demo then?
Yeah. So
okay, let's do it in Node.
Should we? Okay, so now what we're gonna run. This is a TypeScript file, so we get to use this cool flag that Node has that lets you use TypeScript files now.
Yeah.
Then we're gonna run this create identity.
You're running. This only works with Node version 24, right?
Well, we're actually running it on Node 23.
Oh, okay. Well, right.
I haven't tested which versions it works on.
But this one does pull in TypeScript files directly. You don't have to do the compiling and then JavaScript files.
It's not type checking the files. It's just doing a little bit of the transforms TypeScript does, and then throws away all the types.
Yeah.
So it's not actually testing anything, but it is just running the code. TypeScript is doing the checking.
Okay.
So anyway, we need to give it an identity index. This is using hierarchical deterministic wallets with the paths, and so you can deterministically generate lots of identity keys for this. So I've been using this for a while. Maybe we should make a new wallet. I don't know if I want to try to figure that out right now, but I know that I haven't gone up to 40 yet. So 40 is not. We don't have an identity created for this this index yet. Okay. So it's saying we default to sending 1 dash plus a little fee. So I need to fund this. I have some. This is all in the testnet, by the way. So I have some dash over here that I will quickly fund to this address.
Okay.
And we'll send that. And now when I run it again, it will create the identity. And it's looking for the transaction. It found the proof, created the identity. And now if the platform has caught up to this block, then we will see that we just created this identity 10 seconds ago. So we got this brand new, freshly minted identity that we can use for our
And thank you
purposes.
to Mikhail for this wonderful Explorer,
Yes,
by the way. This
Platform
is
Explorer is
what we're looking
beautiful.
at, testnet.platformexplorer.com. Okay, so success on the identity create. We've done that before. Let's move to the next step that we haven't yet shown, but we can
Okay.
now.
So for data, for creating a data contract, we're still going to use the same identity index. And we're going to create a simple identity. This is the schema that we're creating the contract for. So the schema is a document type note, and inside that note, we have an object that has a message property that can be a string. Very simple.
Mm-hmm.
So we can create an identity, or we can create the data contract, and boom, that fast, we have a data contract. Open it up to show you. This one was just created 6 seconds ago. So we have this brand new data contract, and we can show you the schema. We have a property message of type string.
Okay, so yeah, this is we called it a note. That's the schema that we
Yep.
just created as that was our choice of terms,
Mm-hmm.
and we're saying that this note requires a message field that is
Yep.
of type string.
Yep.
And so now, if we wanted to create a document for that data contract, that would be the next step.
Yep. So we create a document. Now this time we need to tell it which data contract we want to create a document against. So we have to put in that, and then we get to give it the message. So we can say, hello, live stream, or hello, viewers, maybe would be better. Since this is also a video, that when I forget that Bash doesn't like, or I think it says like Z shell doesn't like exclamation points.
It doesn't want to be happy, okay?
What am I doing wrong? I am actually kind of confused right now.
Does it need to be a string, or is it just implied to be a string? Do you need the quotes on there? I guess you probably do, yeah.
Oh, you know what? The exclamation point screwed stuff up. All right, I got a new document.
Okay, sweet.
We created this document just 10 seconds ago. We can see that it's typed note, and that our message is hello, viewers.
Awesome. So there you have it, folks. There's the pure JavaScript library.
Data contract that was created 1 minute ago, owned by this identity that was just created 3 minutes ago.
All right, now let's do the bonus demo, which is I wasn't planning to do this, but just before the stream, I was asking about, hey, is this ready for being able to use this? You know, the whole reason that we're creating this is so that developers can create web apps and be able to use these libraries in web apps. So I didn't expect you to, but you were able to just go ahead and build this out, a simple HTML file that imports these libraries and uses it in the web as well. So why don't you talk us through this one?
Yeah, so this is like all of that code does a whole bunch of console logs. Its entire interface is supposed to be over the terminal. So this is not really web ready, like web friendly yet, but it does run in a browser.
Yeah, all the code is functional in the web, which is not, just saying something works in JavaScript doesn't mean it works in the web, because
Right.
Node and the web is two different JavaScript environments with completely different different things. So we had to do so about an hour of finagling to get this to work. But
yeah,
I
so I
think
gotta fund this identity. We can check it again. And of course, we didn't actually test creating an identity before we did this. So I was trying to use the buffer library that doesn't exist in the browser.
An example of one of those things that doesn't work in the
Right.
web, but I thought we had tested the identity, but maybe we were just using a previous identity.
Yeah.
There's 2 and 3.
So first hash, we don't need to even use this. Why do we even have this? Why do we even have this lever? All right, so we can't use the 0 on Q connection to get instant locks. So I think we're going to have to wait for a chain lock. It looks like whatever ZMQ thing AJ had set up, it looks like we would just need to have the CORS policy opening up the ability to access this from other sites. It doesn't look like it's a fundamental browser incompatibility issue.
Okay.
But yeah, that chain lock can take a little while to find, but it should find it pretty soon. And then we should be able to create an identity.
So I thought we had tested this one before we got on the air, but what was different? Was it that last time we got
I
a
tested
instant lock send?
I tested that it would be able to find the identity if it had already been created.
Oh, okay.
I did
So
not actually create an identity in the browser before we
Gotcha.
tested this, so this is my bad.
That's okay. We can fall back on that. Just using an identity that already exists, right? Or no?
Yeah, because we did test that creating a data contract in a document works.
Okay.
But we should get a block. Maybe it's not gonna work.
Yeah, we can give it a little bit of time, and then we can just do the other route where we do the document and the contract and the document from an existing identity.
Yeah, I think there might be some CORS restrictions or something that I'm still not aware of here. I'd have to double check this. It doesn't look like we're getting anything from the chain locks, but it also looks like we're getting responses that say that there is one. So I think something's clearly messed up.
Yeah. Well, let's try the other route then, and then we can come back to this maybe at the end of the stream if we want to, or just leave it for work after the stream.
Yeah. So we just created the identity with the ID 41, so we can see that we already created that. So we can create a data contract against it, which will create a new one, a fresh new one, 4 seconds ago. So we can grab this data contract ID, put it in here, and say, and we can create a document.
Hello from our browser.
Get it right here. So we're getting this new document that we just created, and all of this is running from the browser. Just to show you like what kind of thing is going on here, our index.html file is directly importing those 3 scripts we just ran, and then the buttons are just calling the functions that are in those files. So there is no server backend API that we're calling to run this. It's all running in the browser.
Pure client side.
Purely client side.
Yep. Now there are browser calls to TRP, the rpc.digitalcache.dev to what is that doing? Why don't you tell us about that?
It's exposing the JSON RPC endpoints that are from the core nodes, from the dash core nodes.
But right, but what specific RPC call are we using in this? I think it's something to do with quorums, right?
It's just get raw transaction.
Oh, okay. Okay.
So we're sending the raw transaction, but then there's also get raw transaction. This is where it's trying to find the chain lock.
Yeah, that's Dash core stuff, not Dash platform stuff.
Right. It's trying to find the proof that we locked assets on the core side.
Yep. And that's
And
for
something
identity.
about that wasn't working, and I don't know why, but like it doesn't look like anything fundamentally wrong. It's just some configuration issues.
Cool. All right, now let's look at the. I want to. One of the reasons why this whole effort is what I thought was worth pursuing is to get the performance increased. So performance meaning it does things fast, and also it's not requiring a bunch of bandwidth and time to load in users' apps. So
Yeah.
the wasm builds are on the order of like the current SDK is I had an incubator stream with what's his name? Let's see. Hang on. Just drawing a blank real quick. Caleb. Yeah, our last stream with Caleb, we were using the JavaScript SDK, the existing one, just as testing that to see how quick things were. I saw things taking a minute long. I saw the actual SDK is tens of megabytes. So let's take a look at what people saw how quickly these functions were working. So we don't really need to talk about that, but how big are the libraries and the packages that we're using now?
So all of that functionality was included in the Vite bundle that was just running in the browser. And as you can see, there's like a main and an index file that are like, minuscule. Most of the exciting stuff is in here. The raw JavaScript size is 300 kilobytes, which when it's sent to the browser is usually going to be gzipped or something like Snappy, something even a little bit better, but it's going to end up being around 85 kilobytes.
Less than 100
sent to the
kilobytes.
browser.
So dramatic improvement.
To be fair, though, this SDK is just identity, data contract, and document creation. There's very little to it, and it's all proof of concept code. There's not like a lot of like things to make it easy to actually use it for an end user.
Yeah.
So like take this with a grain of salt. There's going to be more in like a full-sized SDK built with JavaScript.
Sure, but we're I think that's like 2 orders of magnitude. So from best case scenario, 10 megabytes existing down to 1 megabyte down to 0.1 megabytes, 2 orders of magnitude improvement so far. This isn't finished like you said, but it's a dramatic improvement over what we've got currently. And the big question that still remains to be solved is the idea of the proofs. So do you want to talk a little bit about that? Because I did see that Mikhail's team is working on proofs in JavaScript, and he's taking like a fresh approach. So he's not like tweaking the existing JavaScript SDK. He built a new one, and then as a side project, he's also working on he finished a proof of concept for proving that he could verify. I think it was an identity balance proof from GroveDB. That was, I think, on the order of 10 megabytes as well, because it's using wasm. What can you say about the possibility of using some of your auto generation tools that you're using for this, expanding that to the proof system? I don't know enough about it to be able to say one way or another if we have a roadmap towards being able to get proofs in the same way that you've done this other part of the library, but can you talk a little bit about that?
Yeah, so I think we did talk about this at one point, but I don't remember if it was on a public live stream. Anyway, so the WASM proof of concept that I saw It looks like it is actually compiling the GroveDB verification code in Rust into a wasm bindings and then running them from JavaScript. Um, I I looked at this for like less than 5 minutes, so like please take everything I say with a grain of salt.
Yeah.
But from what I understand, the structure of the proofs is encoded with bin code. So in theory, we should be able to use my bin code generator library to generate the code to be able to decode the proofs. We have found a well-respected Noble BLS, Noble crypto library that has the ability to verify BLS signatures, and that's a pure JavaScript implementation for when we care about that. I think there's a wasm bindings as well that's a little bit faster, but we can switch back and forth whatever is necessary for whatever environment we're in. I think that's not the hard part. The hard part then is to actually verify that the proof is a correct proof, and then further to verify that the proof is proving that it is the correct answer to the question we actually asked. And that's just code. I mean, and we just have to write all of that. I don't know how long it will take. I don't really know how large or complicated these proofs get. How many different types of proof elements that we would have to verify. I don't think it would take that long. Like, I don't know, maybe a week or 2 or 3-ish of time to do all of that. Pessimistically guessing. But I don't see
Yeah, I
any
don't
key
want to hold
obstacles
you to any
to.
timelines for sure, because you haven't even looked into this. I just wanted
Yeah.
to roughly speak about,
I
is
don't see
there a
any
possibility?
roadblocks.
Say again?
I don't see any roadblocks, is what I'm trying to say.
Yeah. Just
It may be a long road, but there is a road to get there.
okay. And in the worst case, we were able to collaborate with what Mikkel's doing on the proof side using the wasm, put it into what you've built, and we have a bit of a bulky SDK, but it also has proofs, and that would be a step in the right direction. And then
Right.
you could continue to work on trying to remove that part of the wasm, just like you've removed the wasm that was originally in the original SDK. So just iterative approach, but definitely, I mean, this is already very, very usable from web apps, even that, what we showed. So yeah, I'm super excited about the progress you've made here, Matt, and thanks for your work. So anything else that you wanted to say? We're 28 minutes in, so we're doing well on time. Anything else that you wanted to say, or should we wrap it up? Is there anything else that you wanted to show as far as code or talk about? Yeah.
Yeah.
What else is
So this code is written in a like a it's written in proof of concept mode.
there?
This code is like, if you look at the difference between these 3 things, there's a lot of copy and paste and a lot of like low level, like here's how we actually like insert all of the signatures from all of the identity key, blah blah blah. There's just a lot of junk in here that is not something that an end user is going to want to do. This is not at the moment ready for an end user.
This is, in other words, this is not a proper SDK.
No, it really is not.
Yeah.
What it is a proof of concept that we can do it. Is it going to actually work in the browser? Is it worth pursuing? And I think we have thoroughly answered that the answer is yes. But if somebody was to come to me and say, "Hey, can I use your SDK?" I'd be like, "There is none yet. We can't. We still need to actually build one."
There's essentially a library now, and to make it an SDK, you need to write the right abstractions on. So for any people that are not coders that are viewing this, basically, that to me, what that means is like there's all the hard work of the library is already done. Now it's a matter of making it convenient for people by writing higher level functions that say, instead of me having to do some of the lower level code, you know, in my my web application, um, I just want like a function that says, like the API that you have on your CLI, on your command line interface,
Hmm.
and what you've abstracted away into that simple web app. Like, give me, I just want to know what are the 2 or 3 required arguments to this function, and then you do everything else beyond that in the SDK, which is on top of the library.
Yeah.
So that's, I would say that's easier in terms of, it's more straightforward, but there is still time required to get the developer experience right and to get the right abstractions. What
Right.
what
And if,
would you add
and
to
you
that?
know, keeping ideas like wanting the whole thing to be tree shakeable, so that like if you don't actually care about the proofs, you can just not. I don't know if we even want to try to do that, but you know, just as an idea, if you wanted to cut out a large section of this code
Mm,
and really cut down on the size of this for whatever reason, maybe you're trying to get crypto to people in third world countries with really poor internet access, and you want them to be able to run it on their phone from a mobile browser, you know, you might want to really shave down the size of the library to something really tiny.
mm,
So if you want to be able to do that, you might want to be able to split it up into lots of little bundles where the different pieces all only include the little bits of the code that really is necessary. So like there's some API design decisions that need to be made there, so that it can be tree shaken nicely. We want to make sure there's good documentation. We want to make sure there's good example code. We need lots of tests, lots and lots of tests, which we really don't have right now. What else? There's something I do want to mention. One thing I really want to do is to have a wallet abstraction here. I know that Mikhail has worked on a proof of concept of a browser extension that pulls the wallet out into the browser, which I think is fantastic. I think it would be even nicer if you could pull the wallet into a physical wallet, but I don't know how. That's kind of future work. But I really hate having all of the crypto and all of the wallets and private keys stored in this JavaScript environment that can be hacked in all sorts of ways from all of the little impossible vulnerabilities that may come out.
right. Yeah,
Um,
there's a security usability spectrum that you balance with that.
yeah,
Like, if you want to have a good user experience that's relatively secure, and you're warning people that, hey, don't put, don't put any more than $10 on this or whatever, and it's a nice, just to buy gift cards or something here and there. That's one approach. But if you wanted to have a more secure web app, then what you're saying is have it interface with hardware wallet and have the ability to keep all of your keys offline, but then the browser is asking you to sign things offline, for example. That's what you're saying.
sure. But even more than that, one use case is simply like, hey, they created their wallet. They decided to go and use this application, and now they want to try another Dash application made by someone else. They don't want to put all that wallet crap in there again. They don't want to have to create entirely new separate identities. They want to be able to use all the things they've already set up. And if they already have a wallet installed on their browser extension, then when they switch to a new Dash application, they can just say, hey, this application wants to use your Dash wallet. Do you want to allow it? And then they click yes, and then they're in. The Once they've gotten into the Dash ecosystem, adding a new application to it is really easy, if you have access to like the browser extension. Um,
Yeah, and that's a user experience that a lot of people are used to and kind of demand. And so
yeah,
that then it's a question of getting integrated with existing browser wallets as well. And I can tell you for sure, they're not going to want to put 30 megabytes into their app just to support Dash platform, for example. So that's one of the other reasons why we wanted to trim this thing down significantly, so that there are no excuses from the outside integrator world that say, like, hey, this is too big for us. We don't want to deal with all this,
Yeah.
let alone all the supply chain attack vulnerabilities that it opens up. So there's a lot of other work to be done, but this is, I think, the hard part. Looks like it's like we've proven that we can do all this pure JavaScript. We don't have the proofs yet. We'll work on that. But yeah, things are looking really good. So yeah, anything else that you wanted to add on that?
Nope, I don't think so.
Okay, well, we'll keep it relatively short, 35 minutes. So thank you everybody for joining in. Most of you will probably be watching this next week. So let us know if you have any questions. Post them in Discord or on the YouTube channel, and we'll try to get back with you. And I've been chatting with Mikhail a little bit, so I'm hopeful that we can take what he's been working on with the proofs, take what we've been working on, merge them somehow, and figure out how to get this wrapped up into a good SDK, which it's not quite right now, but the road is there. So, all right. Thanks, everybody, and we'll catch you next time.